Good afternoon everyone. So today we are going to start operation of unbalanced supply on a three-phase induction motor. Okay. So what will happen if unbalanced supply is given to three-phase induction motor? Okay. So normally we give balanced three-phase supply to three-phase induction motor, and due to this, and the windings are either connected in star or delta, which are symmetrical and balanced one. Okay, so when a balanced supply is given to a balanced three-phase winding of three-phase induction motor, which is either connected in star or delta, so there will be a rotating magnetic field which revolves the speed of synchronous with this synchronous speed. Okay, and then it will cut the rotor's conductor, and EMF will induce, and current will pass through this rotor, and rotor will get started rolling. Okay, so this is the principle of induction motor. Now we will see the operation of the induction motor under unbalanced supply condition. Okay, so operation operation one. So, what are the causes of this unbalanced voltage supply? First is when some unbalanced load is connected to the system, and there is or some fault is there. The system, or due to some fault or line disturbance. So these are the so what? So balanced voltage. Let's suppose this is VA, VB, and VC. So balanced voltage, when all the three voltages are displaced by 120 degree and magnitude of these voltages are same. Okay, so this is balanced voltage supply. Okay, so all the three voltages, 9 voltages, are displaced by 120 degree, and the magnitude of these voltages are same. Okay, so this is balanced voltage supply. Okay, so it is necessary to provide a balanced voltage supply, three-phase voltage supply, to balance three-phase induction motor, that is balanced three-phase winding, in order to have a rotating magnetic field which is revolving with synchronous speed, which is equal to 120 F upon T. Okay, so rotating magnetic field will revolve the speed ms, which is equal to 120 F upon T. Okay, so now so these are the conditions. So when unbalanced load is connected to the system, so voltage will be no longer equal to one. The displacement between these voltages is no longer equal to 120 degree. It will be less or more than, and magnitude of this unbalanced voltage, unbalanced voltage supply, so this will be different. Okay, so this is balanced voltage supply when all the voltages are displaced by 120 degree and their magnitude are same. But in unbalanced system, it may be 100 degrees. Okay, so this will be displaced with different angle other than 120 degree, and their magnitude will be will not equal to each other. Okay, so this is the unbalanced voltage supply. Okay, so what does it will give effect on the operation of induction motor? We will see. Okay, so the best way to understand this thing, we will go with symmetrical components. Okay, so first we will resolve this unbalanced voltage supply to symmetrical components, and then we will see the operation of induction motor on unbalanced voltage supply. Okay, so this unbalanced voltage can be split into or decomposed into three components. Okay, so three different sequence of components. First is this is EAP, VVP, and VC. Okay, so this is positive sequence components of voltage. Okay, they will be in same phase with the supply voltage. Okay, and then making replaced by 120 degree respectively, and the magnitude will be same. This is VA and this is VBN. This is not written, this is from negative. This is VC. This is negative sequence. And then third, zero sequence components. They are equal in magnitude and in same direction. Okay, so this unbalanced voltage can be split into this three set of components: positive sequence component, negative sequence component, and zero sequence component. Okay, so this positive sequence has same phase sequence of the original unbalanced voltage supply, and so this will be negative, this will be VC, and this will be VBN. So this will have phase sequence of ABC, and this will be have a sequence of ACB. Okay, so it will have different phase sequence. Okay, with respect to the unbalanced voltage supply. Okay, so its phase sequence is ACB. Okay, so and its phase sequence is similar to the voltage supply ABC, and hence and this is reverse phase sequence or negative phase sequence That's why it is known as negative sequence component of the voltage. Okay, and zero sequence component have no phase sequence. They are uh, aligned in same direction. Okay, and since we are assuming that we are using symmetrical star or delta connection. Okay, there is no neutral connection, so this zero sequence component will be neglected. There will be no zero sequence component, and also they don't contribute in torque production as there is no rotating field due to this zero sequence component. Okay, so we only consider the positive effect of positive sequence component and negative sequence component. Okay, so the field which is produced due to this positive sequence component will be in the same direction uh, in which the uh, unbalanced voltage supply field is. Okay, so they will be in same direction. Okay, so if the direction of the field due to this unbalanced is in clockwise direction. Okay, so the field produced by this positive sequence component will also in the direction of the this field. Okay, and the negative sequence component will be in opposite direction to this. Okay, so this will mean opposite direction. So voltage VA, VB, and VC can be decomposed into three components. So VA will be equal to VA B plus VAN plus VA0. VB is equal to VB, P for positive sequence, N for negative sequence, and 0 for zero sequence. Okay, plus VBN plus VB0 and VC is equal to VCB plus VCN plus VC. Okay, so the VA, VB, and VC are decomposed. So the three-phase set of unbalanced voltages VAB can resolve into three-phase balanced positive sequence, negative sequence, and zero sequence voltages. Okay. Now, and this zero sequence are in same phase, and there are known as co-phase components. So they are co-phasal components. And now this so now the angle between VAB and VB is 120 degree, and we know that this orbital alpha orbital is one angle 120 degree or e to the power of 120 degree. Okay, so this alpha is operator which has an angle 120 degree equal to cos 120 plus j. So PBT is equal to alpha times VAP. Okay. So angle between VAP and PBT is 120 degree. Okay. And VCP is equal to alpha square KVP. Okay. So angle between is 120 degree. So we can write VAB is equal to 1/3 of VA plus alpha into VB plus alpha square into VAN is equal to 1/3 VA plus alpha square VB plus alpha into VC. And VAO is equal to 1/2 VA plus VB plus VC. Okay. So these are the positive sequence component of A, negative sequence component of A, and zero sequence component of voltage phase A. Okay. So now we will find the effect of positive sequence on the operation of induction machine. Okay, and then on. So positive sequence produce an air gap flux wave rotates at synchronous speed in forward direction. So this is induction motor. This is the stator, and this is rotor. We are assuming the air gap flux is revolving with the speed s. Okay, in direction. Okay, so the positive sequence component of voltage will produce air gap flux, which will rotate in forward direction. Okay. So forward direction, by forward direction we mean that. So this rotor is the magnetic field of this air gap is the air gap magnetic field is moving in clockwise direction with respect to x. Okay. So the field produced due to this positive sequence voltage will also rotate in same direction. Okay. So this will rotate in same direction. That is V and S. Okay. So this will rotate in the same direction. So slip in this case for positive sequence slip will be equal to NSP minus NR divided by NR, and here NSP is equal to equal to ns minus nr divided by nr. This will be equal to slip S. Okay, so slip S will be same in case of the field air gap flux which is produced by positive sequence voltage. So this will have same slip. Okay, so SP. So this is a slip due to the positive sequence voltage, positive sequence component of voltage. Okay, so slip SP will be equal to S. And if we draw the equivalent circuit diagram, this will be same as the three-phase induction circuit. So this is R1, this is X1. Suppose this is PV, positive sequence. Positive sequence voltage, and then X2 local side, this is Xn. This is equal to divided by S. Okay, so this is positive sequence voltage. The circuit diagram. First for positive sequence it will be same. Okay. So this is IP given so negative Xn, we can find the value of current I2P. So this will be PV whole divided by R1 plus R2 dash upon S plus J X2 plus. Okay, so this will be the value of total current for positive sequence voltage. And we can find the value of torque due to this positive sequence component of voltage. Okay. So torque T will be P upon omega S into I2P square R2 dash upon S. So through the value of I2P, so this will be P upon omega S. This will be dt square whole divided by R1 plus R2 by S square plus X2 plus X1 plus X2 into R2 dash upon S. Okay, so this will be the value of the torque. Positive sequence torque. Okay. So negative sequence voltage produces an air gap which rotates at synchronous speed in reverse direction. Okay. So what we have assumed, this is stator and this is rotor. So field is rotating in clockwise direction. This is ns. Okay, and the field which is produced due to negative sequence component. Okay, let's suppose this is NS negative sequence NSN. Okay, so this will be in opposite direction. It will rotate in anti-clockwise direction. Okay, so NSN will be equal to minus NS. Okay, so slip due to this negative sequence component Sn will be equal to minus NR divided by NR. NS. This will be equal to minus NS minus NR divided by minus NS, or NS plus NR divided by NS. Okay. So the slip will be equal to Sn, can be written as 2Sn minus NS divided by NS by NS. So this will be equal to 2 minus S. Okay. So slip due to negative sequence component, slip is equal to 2 minus S. Okay. So slip will change. So this rotor now slip will be equal to 2 minus S for negative sequence component. Okay. Voltage. So slip is now 2 minus NS. So now equivalent circuit will change. So this is negative sequence voltage. Okay. So this will be I1P and this will be Q. Now this will become 2 minus S. Okay. So equivalent circuit for P. Now this will be due to negative sequence voltage. Now this will be IN, this will be N, this will be 2 minus S, this is 2 minus S, 2 minus S, so this will be the value of negative sequence torque. Now we have two torques. Net torque will be equal to EP plus P. Okay. So we can draw its characteristics, speed torque characteristics, torque slip characteristics. Okay. So this will be similar to torque slip characteristics of induction motor. And this will be for this is EP and this is P. This is torque. Okay, so this is torque due to positive sequence voltage, and this is torque due to this is for due to positive sequence voltage, and this is due to negative sequence voltage. Okay, so this is something we have studied in single phase induction motor, and we are studying the double revolving field theory. Okay. Okay. So the net torque will be reduced. Okay. So now net torque will be this. So this is net torque. T is equal to EP plus P. So this will reduce the net torque. Okay, so uh, one field is moving in positive direction, in forward direction, which is positive sequence voltage will do the positive sequence, and another field which is revolving in the reverse direction of the synchronous speed. Okay, so this will reduce the overall torque. Okay, so torque will get reduced due to this negative sequence torque. Okay, torque due to negative sequence voltage. So we get reduced torque as compared to the original torque. Okay. So now air gap power due to positive sequence will be equal to I2 T square into R2 into SP. Okay, so this is the R2 upon divided by S divided by SP, which is equal to S, and air gap power due to negative sequence will be equal to I2 N square R2 by 2 minus S. Okay, this is same to S. Okay, so internal power developed per phase. So internal power developed per phase Pg will be equal to Pg3 minus Pgn because it is moving in reverse direction. So this will be equal to 2P square R2 by S minus 2N square R2 by 2 minus S. Okay, so this will be total power developed per phase. Okay, so when only balance phase is given, balance voltage is given, so we have only this power developed I2 square R2 upon S. Okay, and here we are getting this negative sequence. Okay, so this will reduce the overall power developed, and we can find the total power developed, total power output per phase. So which is equal to P out if losses are limited is 1 minus S times G. Okay. So P out will be equal to 4. So this will be different for this. So this will be equal to, this is for balance. For unbalanced, P out will be equal to Pg is this much. So 1 minus S I2 square P R2 by S minus 1 minus S by 2 minus S I2 N square R2 by 2 minus S. Okay. So this is power output. Okay. So you can see the total power output is also, so due to this unbalanced supply, negative sequence component of torque will be there and power will be there, which will reduce the overall torque and power. Moreover, there will be losses due to this component 2 minus S. Okay, so losses will increase. Okay, therefore efficiency will reduce, and there will be it will lead to the overheating of the conductors. Okay, So the permissible limit of this unbalanced voltage is 5%. Okay, so to avoid this overheating due to these losses, we generally connect a negative sequence relay which detects this unbalanced condition, and it will trip the motor if there is heating beyond the preset value. Okay, so we generally use negative sequence relay. Okay. So which will detect this abnormal condition, and it will trip the motor from supply if it exceeds the preset values. Okay. And these torques are pulsating in nature, and this torque is pulsating in nature, and which will produce humming sound, okay, and which will reduce the life of the motor. Okay. So these are some disadvantages when three-phase induction motor is connected to unbalanced voltage supply. Okay. So due to negative sequence component of voltage, MMF will produce in the air gap, which will rotate in the reverse direction of the synchronous speed. Okay, which is produced due to positive sequence component of the voltage. Okay, so due to this, negative sequence torque will produce due to this magnetic field, electromagnetic flux. Okay, so this will oppose the main torque. Okay, and it will reduce its net value. Okay, so torque will get reduced. Power will also reduce. Okay, so net power output will also reduce, and there will be some pulsating torque will be there, which will reduce the life of the motor, and which will produce a humming sound. And also, S slip is slip of the uh, negative sequence torque is 2 minus S. Okay, field which is revolving with 2 minus S. So losses will increase and efficiency will also increase. Okay, so these are some disadvantages when unbalanced supply is connected to the induction. Okay, so any doubt?